Hi there everybody, welcome back to the Chem Complete channel, and in today's lecture for statistics we are going to be talking about sampling methods in statistics and the different methods that we can use in order to ensure that we have a random unbiased sample that will be useful for a study. So that is coming up on the channel right now. Okay, thank you so much for learning with Chem Complete today. And again, remember to check out chemcomplete.com for all of your learning needs. There are lots of free resources over there, and it's a great way to support the channel. So on to sampling methods in statistics. First of all, what is sampling? When we define sampling for a study, we're talking about the way in which subjects are going to be selected for a study that is going to involve data collection. So we have to collect our data somehow from the individual subjects that are going to make up our sample to represent the population. And the question is, what are the different ways that we can go about doing this that are legitimate or will not invalidate the results? So you can see the note that I have here with these stars next to it, and that's because it is so important. All valid statistical sampling is random and unbiased, meaning that whenever you collect your data, you should not have any bias, whether it is yours or some other unseen bias that is in the sampling system, and it absolutely must be random. So what are the different methods of sampling that we can utilize when we are getting ready to collect data? So the first one is known as true random sampling, or just random sampling. I usually call it true random sampling because all of these should technically be random samples. Okay, so this is going to be a situation where all members of the population are going to have an equal shot at being picked for data collection. And in order to do this, you would need access to the entire population, or at least a very large set of it that's within practical reaches of what you're working with. And then you would need to randomly select individuals or subjects from that population using an official random method. So some of the best ways that you could do this would be to randomly assign numbers or values to each individual in the population, and then using something like a random number generator, you could randomly select individuals until you have met the quota or the amount of subjects that you need for your study. You could also do some sort of a fair and random lottery type of system where all of the names would get put into some sort of a database and then you would pick out at random. So from a more classical perspective, if you weren't using technology, you're talking about kind of the names in a hat, right? Everybody puts their name in a hat, it is mixed up thoroughly, and then at random you select a name from that hat, and that would be true random sampling. Now what you need to be careful about is proximity and convenience. So as humans and even as statisticians, we have a tendency to want to go to what is close by, what is easy, what we have access to in order to collect data. Collecting data can be very expensive, it can be very time consuming, and we have to kind of consider a give and take in terms of some of those balances. We certainly don't want to go bankrupt or not ever complete the experiment at all because of limitations, but it is also not a good idea to simply sample due to proximity and convenience because it's right in front of you when you may have access to others. Okay, so an example of this is, let's say that you're working with the opinions or the feedback of college students on a campus. It would not be appropriate if you were doing this project to simply sample people that directly sit next to you in class. If you are truly trying to get a wide range of the opinions in terms of what the college students think on that campus, you would need to reach out to all the college students in any way possible, whether that's putting up flyers, setting up a station where there would be heavy traffic potentially coming by, okay? And even those could potentially fall into convenience where it's like, where are you setting up the table? At what time are you setting it up? If you only took evening classes, you're missing everybody during the day. I don't want to go too far down that rabbit hole, but basically avoid proximity and convenience wherever possible. You want to try to be as truly random as possible. Okay, now the second way that we can collect data is called systematic sampling. And as the name would suggest, you're going to create a system from a pool of candidates, and you will select every certain number. So with systematic sampling, the sample will be obtained by selecting, and you can see in quotations here, every nth, meaning you're going to pick a random number or you're going to decide on a number, and every nth number of the population will be where you select from. Okay, so an example here is I have a small town with a population of 2,000 people, and I need 50 subjects for my research project. So 2,000 divided by 50 would give me 40. So I'm going to use the census for the town and sample every 40th individual on the list. This would be an example of systematic sampling. Now there's some considerations that you have to think about here, which is that starting with the top of the names is technically not random. You are being handed a list, and whether it's by address, whether it's alphabetical, that list has been organized in a certain way, and so you're technically not pulling randomly if you're starting from the top of the list. So what you would really want to do is say, okay, I've got a list of 2,000 individuals. Let me use a random number generator to decide where the starting point will be, and then I will sample every 40th individual from there. So let's say I put it into a random number generator and 1,522 pops out. Then I go to individual 1,522. That's my first sample. And then I go every 40th, right? I might need to reset the list if I hit 2,000 and go back to the top, but I pick every 40th from there. You also have to be aware of how the list is going to be ordered. So if you have a list and it is highly structured by family or by some sort of other criteria, let's say that we have a list of all married couples and you are trying to find random opinions on marriage or something related to, who does more chores or something like that, right? If you have a list and it is ordered wife, husband, wife, husband, wife, husband, and you say, I'll take every 10th. Well, then you're going to hit husband, husband, husband over and over again based on that way of sampling. So even though it may appear random to you, if you're not aware of the way that the list is ordered, you could be introducing an unknown bias to it by constantly picking only from the same set based on the ordering of the list. So just some considerations to think about there for systematic sampling. All right, so the next one is called stratified sampling. Now, stratified sampling is going to be when you obtain a sample set by dividing the population into subgroups. And usually these subgroups are going to be based on some sort of category or characteristic that you're looking for. And then you are going to randomly select from each of those subgroups. All right, so an example here is that you have a high school opinion on lunch quality for the cafeteria, and this only involves high school students. So if you were at some school where there would be middle and a elementary or lower school in the same building, we're only interested in the high school or the upper school students while we're doing this. And so what would this look like? Well, you could turn around and you could say, I've got the upper school students, and that is who I'm interested in as my population in terms of the opinion for the survey. And so from here, I'm going to create some groups, and I am going to do it by grade. So I will go ahead and I will have one where I place all 9th graders into that. I will have another where I place all 10th graders in. I'll have another that has the 11th graders. And then finally, my seniors, my 12th graders, I will put into another subgroup. And so if I have these here, then what I would do is I would say, okay, let's say that I need, I don't know, a total of 15 opinions or, people to fill out this survey. And so if I need a total of 15 here, or let's make it 12 based on the numbers here. Okay, so if I need a total of 12, then I would need to grab 3 randomly from each of these groups, right? So I would go in and I would start randomly picking from the 9th grade, and I would need to do that 3 times. I would need to randomly pick from the 10th, the 11th, and the 12th, and then I would have my random sampling. So that would be an example of stratified sampling. I'm stratifying into these multiple subgroups, and in this case it's based on grade level, and then I would randomly pick from them. Now keep that in mind because it's important to understand the difference between stratified and cluster sampling, which we're about to look at as the last one here. All right, so for cluster sampling, we're going to have a sample that is obtained when we divide the population into clusters, which sounds similar into the subgroups where we do stratification. Okay, but then we're going to randomly determine which clusters to use. So we break apart these groups into clusters, but we do not take from each cluster like we did in Stratified. That's the big difference here. We're going to take entire clusters at random, and we are going to pick them as the samples. Okay, so here's an example. You're going to go out and you're going to find all branches of a fast food chain restaurant. I don't know, Wendy's, McDonald's, Burger King, something like that, right? In a given area. So maybe a specific zip code or area code, right? The area code's probably going to be a little bit larger in terms of the number that you would find there, or maybe it's by state or something like that. Okay, so you find all the branches of that fast food chain restaurant. Each restaurant is a cluster of workers. So let's say that we want to look at worker satisfaction at that particular chain. You can randomly select the clusters then. So let's say that I look at this and we'll just say it's by state. Okay, and let's say that this state has a total of 9 of these fast food chains. I know most states would probably have more, right? So we'd have 1, 2, 3, all the way up through 9. So these are the 9 individual restaurants. All of these would have a set number of employees there, right? And then I could go to my random number generator and I could say, hey, between 1 and 9, give me 3 different numbers. And let's say that it says, okay, you got restaurant 5, and you got restaurant 7, and you got restaurant 2. And those were the numbers that it picked out. So then these are the ones that filter out, and I go and I do my interviews or my surveys or whatever it might be with this particular set. So it would be group 2, 5, and 7. And within there, I would go and use those clusters that have been randomly sampled, and I would interview all of the individuals that fall into those particular groups that were selected. So that is cluster sampling. Okay, so those are the 4 main ways that we have for legitimately sampling. Again, you want to avoid some other methods like convenience sampling and things like that. You certainly could do that. However, you are more likely to introduce bias that's coming into your sampling. And again, if we go back to this main point, you need to remember all valid statistical sampling is random and it is unbiased. So that concludes the sampling methods for statistical analysis. Again, head on over to chemcomplete.com. You can show your support over there. Like the video to help us with algorithm boosts if you found it helpful. If you leave a comment, I'll try to get back to you if you have any questions. And other than that, subscribe to stay up to date, and I will see everybody in the next lecture. Thank you so much for learning with me.